there, are you ready for scenario 2? This is the same problem that we looked at last week with the child on the swing, but again, just kind of like we did with the yo-yo problem, just sticking some numbers in to do a little more analysis. All right, so we've got Miriam, who's got a mass of 19 kilograms, swinging on a tire swing with ropes that are 5.6 meters long while she was being pushed by her mom. That's me. It says draw and label a free body diagram and write the F-net equations to accurately represent her motion. So you've done that before, but we'll do it again. More practice means more fun. And then if she's moving at 3.2 meters per second at the lowest point, determine the centripetal acceleration and tensions in the rope, or tension in the ropes, excuse me. All right, so let's go ahead and draw our free body diagrams to get started. So remember, this is when she is at the very bottom of her swing. I am not touching her. She's just swinging along. So the things that are pushing or pulling on her, well, we got the earth because, that's always going. So the force of the earth on, I'm going to go ahead and just call it the child. And that includes both Miriam and the swing kind of all in one thing. Okay, one system. That's going to be my FG. And then there also is a force pushing up, right? And that is the force of the of tension. That's the force of the rope or the force of the chains or whatever you want to call it. So I'm going to call it the force of the rope on the child, and that is FT, okay? At this point, at the very bottom of her swing, there is nothing pushing her to the right or left. We're assuming, as we always do, no air resistance, okay? And we've got just those two forces acting. We'll go ahead and write our F-net equations down in just a moment. But let's write our givens down just so we don't forget to do that. Okay, so if we write down our givens, looks like we know the mass is 19 kilograms, okay? And the ropes are 5.6 meters long. So remember we talked in class about how it's not like she's actually going in a circle, but if you look at the motion of a swing, it does make a part of a circle, right? And the length of the ropes really represent the radius of that circle. So that 5.6 meters is really the radius of the circle or the sector of the circle that we are looking at, okay? Looking along here, it says if she's moving at 3.2 meters per second at the very bottom of the swing, and then we're going to do some calculations with that. So we also need to have that velocity. That is a tangential velocity, and it's nice to write that v sub t, just so we don't forget that, is 3.2 meters per second. Okay, so those are the three givens that we know, and then it asks us to find the centripetal acceleration tension in the ropes. So that would be A sub C, and then also F sub T. Okay, so those are the two things we don't know. Now let's go ahead and write down our F-net equations. So if we take a look at the free body diagram, there are no forces acting in the x direction, like none. So we're just going to go ahead and write down 0 because there are no forces, which means there's no acceleration in the x direction. All of the acceleration, all of the forces happen to be acting in the y direction. So we've got Ft and we've got Fg. We know Fg is going in the opposite direction, so I'm definitely going to include that negative sign there, okay? And then we know that there is acceleration in that direction. Oops, let me put my M first. And we know that because she's going, sweeping out part of a circle, that is a centripetal acceleration, okay? Now you have drawn these free body diagrams a bunch where you've got a tension force and a gravity or a normal force and gravity, and they're in magnitude opposite in direction, and the object is sitting at rest and it is not accelerating. So it's important to note here that there is acceleration and therefore there has to be one force bigger than the other. We know that as she's moving, so here she is right at the middle of her swing, there is a force pulling her this way. The net force is pulling her this way, causing that acceleration upwards towards the center. It's a center-seeking force, okay? All right, so let's go ahead and solve for A sub C. I'm going to do that actually without using my F-net equation because, as I recall from before, centripetal acceleration is equal to v squared over r. And I already know the v and I already know r. So really I can just plug this in right now. So I've got 3.2 meters per second. I'm going to remember to square that quantity. A lot of times when people struggle with this equation, it's just because you forget the squared. So just make sure to take care not to forget that square. And then I've got my 5.6 meters on the bottom. I'm going to go ahead and plug this in. You've got a calculator in front of you. Do it as well. Just making sure that you're not getting mixed up with any of the goofy calculation stuff, because really that's pretty straightforward and easy to do, but also easy to make mistakes on. We want to make sure that you've got a solid foundation for everything that you're doing. So I got 1.83 when I plug that in. It's an acceleration, so that's meters per second squared. Double check that, and if you need help, let us know, of course. So I've got that acceleration, and now the reason I wanted to do that first is in order to solve for ft, I need that ma sub c, or that a sub c. Looking at what else I know here, I know m, and now again I know a sub c. I don't have anything written down for fg, but if we're clever, we can remember that we know how to calculate fg. Fg, remember, is m times the acceleration due to gravity, mg. So we can go ahead and calculate that quick here. So that's going to be, we've got a mass of 19 kilograms, and we're going to multiply that by 9.8 meters per second squared, reminding ourselves that the negative has already been taken into account, so we don't need to take it into account again. So 19 times 9.8, you're plugging that in as well. I got for that 186.2 newtons. All right, so now I'm going to just kind of rewrite this because it got a little bit messy over here. I apologize for that. I'm going to just rewrite this right over here and say green. Ft, that's the thing we're looking for. Remember, that was one of our unknowns, is equal to ma sub c. And then I'm going to add fg to both sides because it was a negative before. So I've got plus fg. So now we can plug in some numbers. I know the mass was 19 kilograms. The acceleration, the centripetal acceleration, that's the net acceleration that she's experiencing, is 1.83 meters per second squared. And then I'm going to add that Fg, which is 186.2 newtons. And I can plug all of that in. Again, you should too. Everybody's having fun. Everybody's doing physics together, okay? Add the 186.2, just narrating a little bit in my story there. And I get something like 220.97. That's a lot of sig figs. So I'm going to go ahead and write 220. That seems a little more reasonable. Okay, hopefully that made sense. As always, ask questions if you've got them.